Ever get that feeling like, the ground we walk on isn't actually all that solid?
Yeah, it's a weird thought, right?
It is, but it's true. The Earth's surface, well, it's constantly in motion.
Always shifting and changing.
It's kind of like a giant jigsaw puzzle.
Except the pieces are massive.
Yeah.
And they're always slowly rearranging.
Exactly. Today we're diving deep, really deep, into the forces that shape our planet that make it what it is. Tectonic plates.
We're talking volcanoes, mountains, even earthquakes, and all thanks to these giant slabs of rock.
Pretty wild when you think about it. So, okay, let's start with the basics for anyone tuning in who might be new to this whole concept. What exactly are tectonic plates, and what makes them, well, move?
Okay, picture this. You've got the Earth's crust, right? Imagine it's like a cracked eggshell.
Okay, got it. Cracked eggshell.
Each piece of that shell, that's a tectonic plate. These huge slabs of rock floating essentially on this semi-molten layer underneath. We call it the mantle.
The mantle.
Okay. Now, deep down in the Earth's core, there's intense heat. That heat creates these currents in the mantle, convection currents. Think of like a lava lamp.
Ooh, I like that visual.
Hot stuff rises, cooler stuff sinks, and it's this constant cycle. And that cycle, it drags those tectonic plates along with it.
So they drift, collide.
Exactly. They grind against each other and all this action. That's what shapes our planet's features.
It's this slow motion dance over millions of years.
Right.
Amazing.
It really is. But, not all plate interactions are the same. There are different ways they can interact, and that leads to, well, a whole lot of variety in what we see on the surface.
So different types of plate boundaries.
Exactly. 3 main types: constructive, destructive, and conservative. And each one, it creates its own unique set of geological features, like think volcanoes, mountains, things like that.
Okay, I'm hooked. Let's break it down. Let's start with constructive boundaries. What happens there? Like, what happens when those plates decide to, part ways?
Picture 2 giant conveyor belts,
Yeah.
right, moving apart. That's kind of what's happening at these constructive plate margins. Plates diverge, create gaps, and those gaps, they allow molten rock, magma, to rise up from the mantle. And as that magma cools, it solidifies. It forms new crust, new land.
The Earth's growth zones. So cool. Where can we see this in action?
Well, a prime example, it's actually underwater. The Mid-Atlantic Ridge.
Oh, I've heard of that. Isn't that like a giant underwater mountain range?
Yeah, it stretches for thousands of miles. It's where the North American and Eurasian plates, they're pulling apart, creating new ocean floor.
Wow. Okay. And so above the surface, any examples there?
Iceland. With all those amazing volcanoes, it's sitting right on top of that ridge.
Right. Iceland. Okay, so that brings me to my next question. Volcanoes. We've all seen images, but there are different types, right?
Yeah.
How do those types relate to all this plate boundary stuff?
Good question. The type of volcano you get, it's often connected to the type of plate boundary it's on. So at those constructive margins, like the Mid-Atlantic Ridge, you tend to find shield volcanoes.
Shield volcanoes. Okay, what makes them special?
Well, they have these gentle slopes. That's because the lava there, it's pretty runny, spreads out easily.
Like classic Iceland eruption images.
Yeah.
Rivers of lava.
Exactly. But then you have those other volcanoes, the ones that are more, well, explosive, make headlines. Those are usually a different story.
More like Mount Vesuvius erupting and burying Pompeii kind of story.
Exactly. You're thinking of composite volcanoes. And those, you usually find them at destructive plate margins.
Destructive, so where the plates are colliding.
Yes. So at these margins, the plates, they converge. One plate, it gets forced under the other. We call that subduction.
Subduction.
And the plate that goes down, it melts. And that creates magma. But this magma, it's thicker, stickier. That's what creates those classic cone-shaped volcanoes with the steep slopes.
Like Mount Etna.
Exactly. Mount Etna, Mount Fuji, those are great examples. And that thicker magma, that's what makes them so explosive.
Because the pressure builds up.
Exactly. That viscous magma, it doesn't flow as easily. The pressure builds, and when it finally erupts,
Kaboom.
basically. And it's not just volcanoes we get at these destructive plate margins.
You're going to say earthquakes.
Right. As those plates grind and push against each other during subduction, there's this immense pressure, this friction. And when it finally releases...
Earthquake.
Yep. Those zones are some of the most seismically active areas on the planet, no question. So destructive boundaries are a double whammy. Volcanoes and earthquakes.
Double trouble. Okay, so that's destructive. What about those huge mountain ranges? Like the Himalayas, how do they fit into all this?
Ah, the Himalayas. That's what happens when 2 continental plates collide. They're both too buoyant to subduct, to go under the other.
So what happens?
They buckle. They fold, they create those towering peaks. And, the Indian plate, it's still pushing against the Eurasian plate, which means the Himalayas. They're still growing.
So they're getting taller. Wow. It's wild to think that all that activity deep inside the Earth can create mountains like that. Okay, we've covered constructive and destructive. What about that third type, the conservative boundaries?
So at conservative boundaries, plates are sliding past each other horizontally.
So no new crust being made or destroyed.
Right. But the friction between those plates, still massive. You still get powerful earthquakes.
So even places that seem stable can get hit hard.
Oh, yeah. Take the San Andreas Fault.
In California, right?
Yep. The Pacific Plate and the North American Plate, they're constantly grinding past each other, makes it one of the most earthquake-prone regions in the world.
That's scary but fascinating at the same time.
It is. And speaking of fascinating, we can't forget about hotspots.
Oh yeah, you mentioned those earlier. What are they exactly? They sound kind of mysterious.
They are kind of unique. Hotspots, they occur away from plate boundaries. They're thought to be caused by these plumes of super hot magma rising up from deep within the mantle.
Like a blowtorch under the Earth's crust.
A great analogy. And as a plate moves over that stationary hotspot, that intense heat melts the crust, creates volcanoes.
Ah, so that's how you get volcanoes in the middle of a plate.
Exactly. The Hawaiian Islands, perfect example. Each island is basically a point in time where the Pacific Plate moved over the hotspot. It left behind a whole chain of volcanic islands.
So each island is like a volcanic time capsule. Amazing. We've covered a lot today, from those tectonic plates to volcanoes and mountains to earthquakes. It's all connected. But if our listeners take away just one thing from all this, what should it be?
I think the most important thing is just remembering that the Earth is dynamic. It's always changing, always evolving. Plate tectonics, yeah, they create beautiful landscapes, but they also create hazards. And understanding how they work, that helps us prepare, mitigate those risks.
It's a reminder that, even though we feel like we're standing on solid ground, there's a whole lot happening beneath our feet. This deep dive has been incredible, a real eye-opener.
Glad you think so. It's a reminder of just how powerful and interconnected our planet really is.
It really is. Well, that's all the time we have for today. Thanks for joining us on this deep dive into the fascinating world of plate tectonics.
Thanks for having me.